Hello, everybody. How's everybody doing? I hope you can hear me okay. Lately, I seem to have some problems with sound and video. So just want to make sure. Let me know in the comments section if you can't hear me, okay? Let me know, please. Uh, Will's working. Tesla's Apple. Well, it's good to be working. I hope you're listening also. Okay, Tesla. Thank you for the note. Anyways, what am I going to talk about today? Well, the other day I had a little bit of an interview with JF Gariupi, I think that's how he pronounces it. And there were comments after the show, um, both on his show and elsewhere. And when I look at all these comments, I arrive at one conclusion, and that's that we have a serious problem with a notion of what science is, what physics is. That's the whole problem. It goes to that level. You have to go all the way down deep and figure out what is science, what is physics, because all these people have a different version of science and physics, what they learned in high school, what they learned in college. And so they ask questions like, uh, where's the proof? Where's the evidence? What experiment can we run? What measurement can we make? What readings can we take? What equation is there? What did you observe? How can we observe the ropes or things of that nature? And anytime they use those buzzwords, I know that the person has no idea, what science is about. And that's where the problem is. The problem is their notion of science. And I don't know, maybe I got to start every presentation, every lecture in the same way with an introduction on what science is, what physics is. These people are not aware that there's been a change, paradigm shift, starting in the 21st century. Okay, we have a different notion of science. That's why we call it rational science, and that notion has to do with explanations. And this is what science is not. And I put this up here so that people can follow along. Okay, in science, we do not observe or study anything. I mean, anybody can study. That doesn't mean you're going to understand. That's the issue. You can study birds all day long. You don't know what they're doing. Studying alone doesn't do it. You can study for a test also. That's not going to do it either. You're going to have to understand if you're going to do science. And people don't realize this. People think that science is just an ongoing activity where you search and never find. And this is the notion that's been driven into their heads in high school and college. We don't analyze, we don't predict, we don't do predictions for sure. Famous word of mathematical physics. We don't do collection of data or math or equations. And people lose their heads on this. They say, what do you mean we don't do math? What do you mean we don't do it? We've been doing equations for the last 400, 500 years. You're going to change all that? Well, we have to go with the definition of science. What is science? What is physics about? Is it about running experiments, about presenting evidence? Is that what science is about? Is this a court of law where you're going to try to convince the jury? Is that what science is about? Or is science about explaining a phenomenon? For example, if we look at a very common phenomenon such as gravity, right? Does trying to figure out how gravity works, how Mother Nature does that little magic trick, that invisible trick, is that a part of science? Because if it is, saying that you're just going to study it forever, 10,000 years of studying it, never understand it, is that science? Or is science answering the question and saying, okay, I can tell you how Mother Nature probably does it? So you have to include, if that is a part of science, if that is a part of physics, then you have to incorporate it in somehow in the definition of science, in the definition of physics. You can't just leave it out there and say, well, all we do is study. The study of, typical for physics, the study of matter and energy. I mean, yeah, you study matter and you study energy. What does that mean? You just study it and that's it? You say, yeah, I read a book about it. Did you understand anything? No, I didn't understand anything, but I read it, I studied it. Is that science? No, science is answering questions. Science is the results of doing your study. Science is the results of doing your experiment. Science is results. And by results, I don't mean that you create some device out there. No, when I'm saying it's a result, I mean it's what did you derive in conclusion? What is the mechanism you propose, especially for how Mother Nature does her invisible stuff? I mean, we already know the visible stuff, and that was the main point I try to get across on JF's program. We know the visible stuff. We know an inclined plane. You roll the ball, we see all the objects there. You know the ball's going to fall down. If someone says, "How did the ball end up on the floor?" You say, "Well, I know. You put it up there, it rolled down the inclined plane, and it went down." We see all the objects. There's no mystery. Or a pulley, you pull on a rope and the pail goes up, and you say, "Okay, I understand it perfectly well." Why? Because you see the guy pulling, you see the rope, you see the little wheel, you see the pail, you see it all. It's a movie that you're watching, and you visualize every item. You say, "I know how the pail got up there. He pulled on the rope through the pulley, and it got up there." Did you need to take any math? Did you need to take some advanced calculus? Did you need to know what force is or what energy is? Are you going to explain it in terms of fields? No, you're going to say he pulled on the rope and the pail went up. That's how you would explain it. How did the window break? A brick went through the window, or the ball went through the window, and that's why the glass is on the floor. That's how you would explain it. So why do we make a difference when we're looking at Mother Nature's invisible phenomena, invisible mechanisms? Why do we make an exception with gravity, with magnetism, with light? Why don't we do it the same way? What's different? We're trying to explain a mechanism. And if explaining a mechanism is part of physics, if explaining a mechanism is part of science, you have to somehow incorporate that event, that understanding, into the definition of physics and into the definition of science. And no one has ever done that. That's what's changed. That's where the paradigm shift occurred at the beginning of the 21st century. Okay? And so, yeah, I like to put what science is not. This is what physics is. Physics is a branch of science. It deals with objects, causes, and mechanisms. And finally, we can go in here with the what we call the foundations of physics. We have the golden principle that you cannot do physics without an object. You can't, physics does require an object. And the issue there is that you have to be a materialist to be a physicist. And people don't always understand that. What do you mean you got to be a material? Yeah, you got to be a materialist, okay? And people have a hard time with that, especially if they're Buddhists or whatever, right? They have a little bit of a hard time there because they say, well, there's this consciousness that also exists out there, and love exists, and they have all these concepts that exist out there. And so we were forced to define the foundations, the cornerstones of physics, because they're introducing religion. They're saying love exists, consciousness exists, not in physics. Maybe in religion, maybe in ordinary speech, maybe in mathematical physics, not in physics. In physics, only objects exist, and only objects serve as mediators, and the entire universe runs with objects, both invisible and visible. There is no such thing as a concept flying around out there. And for these people, this is a total shock. They can't accept that. They say, what do you mean? Of course love exists. Of course spirits exist, God exists, angels exist, energy exists, mass exists. No, concepts do not exist. Only physical objects can be said to exist in physics, and only they can be moved around. And so, what is the problem with the electric universe, our subject for today? Well, the problem there is that Not only they do not define their key words, right? But they don't use objects. They use concepts. And they inherited that language from the establishment, the same establishment they criticize. That's where they got all that language from. I know because, when you go to college, you learn all that language. I studied engineering and you learn all that language. They give you all that language. You must memorize it. And yeah, you go in there and you apply it. And it's like, yeah, I understand. Energy went this way and fields went that way and mass, I pushed the mass upwards. You have no problem with that until you start thinking, well, how does Mother Nature run her universe? And then you can't use energy, mass, fields, time. You can't use any of those words because Mother Nature doesn't recognize them. Now you got to do physics. Now you got to do it with objects. And that's something that people are not so used to. They think they can continue doing mathematical physics using the language of mathematical physics, which is the movement of concepts. And they do it inadvertently. They think it's natural to them. And when you stop them and say, look, you're moving a concept, and they say, hey, you're doing semantics. You're doing ontology. You're in the wrong field. You're doing philosophy. No, it's the other way around. The guy who's doing philosophy of the worst kind is the guy who begins to move concepts around. The guy who says that consciousness moved from here to there and that there's something other than matter and that's consciousness. That's the guy who's doesn't belong in physics. Physics is materialistic 150%. He who does not accept materialism is out of physics. He's not doing physics. That's the issue. And that's the paradigm change, the shift that's occurred at the 21st century. Anyways, where did we leave off the other day? Well, we left off with this, the conclusion. So I'll start with the ending rather than with a beginning, okay? And the reason I want to do that is I want to cover a couple subjects or go over them again one more time. I want to make sure that people understand what the issue is with the electric universe, okay? You need to understand what the problems are. So if you come across Wal Thornhill, head of the Electric Universe, or David Talbot, one of these guys one day, well, you know what questions to ask them. You know what you want to know or what is not clear to you. And I want to show you what is not clear right now, okay? And so here we go. These were the conclusions of the other day. Let's see if I can make it a little bigger here for me. Proponents of the electric universe do not define the strategic terms that they're going to use, specifically plasma and electricity. I mean, electric universe, you would think that electric would be defined. Just like flat earth, you would think that they would define the word flat. Neither the flat earthers define flat, neither the electric universers define electric. There we have already a poor starting point. You need to know what electricity is exactly, perfectly, if this is your theory, if your theory is going to be based on electricity. And electricity based on plasma, it turns out they don't have a definition for plasma. They have a very loose one, and even worse, even if they have one, because they have really two. One is that it's a category. It's a category of states of matter. And of course, if it's a category, it's obviously not a physical standalone object. That already removes the word plasma from the list of objects in physics. But in addition to that, they say, well, plasma is the ionization of an atom. You know, you remove an electron, now it's ionized. Well, you had to do something to the atom. That means it's a dynamic phenomenon, not an object. It's not a standalone object. And people have a hard time at the electric universe. They have a hard time understanding that. See, there's nothing wrong with them dealing with beads, with electrons, and with proton bowling balls. No problem there. You know, if you say, look, the bead moved this way, the proton moved that way, no problem. But you can't say the plasma did this, the plasma did that. They don't understand that. And part of the issue there is that they know that if they give into that, it's like the Christian who gives a God or Christ. You know, they lose their whole religion. So they can't let go of plasma. And that's part of I think part of the problem. Both words are defined as objects, standalone objects. They're not their concepts, okay? And this is a non-trivial semantic issue. In other words, this is non-trivial. They might say, well, it's semantics. You're doing philosophy. You're playing around with words. No, this goes to the root of their theory. This is important. In other words, Here you have to define these terms because it's the cornerstone of their theory. That's the problem. So you can't just let this one go. No. And yeah, we're going to be doing semantics for 2 years on those two words because, unless you get them cleared, we're not going to understand your theory. You're not going to be able to understand your own theory. So yeah, you need to define these terms. You can't get away with that and say, well, I'm not going to define it. I'm just going to tell you my theory. No way. Okay. And positive and negative, they use that constantly. They have never defined it. They have never determined what positive and negative mean in physical terms. That's the issue, okay? And then they use the planetary model. If an electron bead orbits the nucleus, okay, the proponent has to explain the mechanism that prevents a spontaneous escape of the bead. I mean, what keeps the bead bound to the proton? They need to explain that. They can't get away from that mechanism. They can't say, well, we don't know, and we're still investigating. We're trying to figure out. No. If you're going to give a theory in front of a crowd and say, look, I'm going to explain how this universe works, which is what they're trying to do there, right? And you're going to start your presentation, say, this is my atom. Here's the proton. Here's the electron. They have to answer the question. And the question is, what keeps the electron bound to the proton before you ionize it? And they can't get away from that question. If they get away from that question, they're eluding a very important part of what they're going to be talking about. They're not going to explain the connection between the electron and the proton. What are they going to say? Positive attracts negative? And that's exactly what they say. Positive attracts negative. Oh, no kid. What does that mean? In physical terms. And finally, the EU purports to replace Newtonian gravity with electricity, but there is no electricity level plasma in the universe, in the solar wind, and anywhere out there, in space. They say space is filled with plasma. We're going to argue that that's not the case, not at all. Okay. So continuing here. This is one of the pieces of evidence because, the electric universe is strong on evidence. And they say, look, we have the evidence for electricity and for plasma, for what happens out there. They don't define these terms, but they have the evidence. That's great. Okay, so what's the evidence? Well, they said, look, here we have the cosmic filaments on the left. That's what we see in the night sky with good telescopes and so on. We took this picture. Okay, great. And they say it's just like lightning. See, they have very great similarities, right? Because if you look at those, they look pretty much the same, don't they? But they're cheating because that's a bad analogy. This is the analogy here. This is the way they're supposed to be looking at this, okay? Because lightning is something that comes and goes every 2 seconds. And that's not what we see. That's not what we see on the left-hand side. The left-hand side, we see something permanent, okay? It's not like we're seeing this kind of activity out there in the night sky. So this is a very bad analogy, and they use it only for visual purposes. Again, they're strong on evidence and very weak on delivery, on arguments, on theories. That's where they're weak. So they show a lot of evidence. And here, let me show you a few more evidences that they put out there. And they all have to do with experiments. Again, experiments are not a part of science. That's what they do. 90% of what they put out, like on YouTube, experiments. They say, look, let me show you an experiment. What are those experiments for? Well, they want to show you that here on Earth, with electricity, some form of electricity, they can produce holes, they can move sand around, and they're trying to imitate what happens on Mars, what happens on the moon, what happens to some of these rocky planets. They say, look, we can imitate all that. That's how they came to be. Okay? And so let's look at some of this evidence that the electric universe works very hard on. Here's one of them. This is all from their site, by the way. This is all theirs. I'm going to show a few of them. This guy is burning a hole there. Okay? He shows how it's done. This is done with electricity. And then he says, okay, this is the way it is. This is what it creates. It creates these craters. Okay? These holes that we see out there in Mars and also here on Earth. So they were made electrically, just like he's showing there. Here's another one, number 2, okay? Shows all this. He says, look, I can burn these holes. I can blow some wind across the sand, etc. They do all these little things, and then they show you that this imitates what they see out there in the night sky. When they take very close-ups of the Mars surface, the Martian surface. Well, they say, this is how it was done. It was done by the gods or whoever, but that's how it was done. And here's another one. The guy just runs his little stick there, his electric stick across there, and he says, "See, that's how it's done on Mars or on the moon, or on an asteroid." They're showing you how they can reproduce what they see in these planets by showing you how they do it here on Earth. Okay, here's another one. Again, they make a hole in that little mountain, volcanic type thing. Okay, and they say lightning scarred planet Mars and so on. Okay, so they're showing you all this. What are you staring at? You're staring at evidence. That's what you're looking at. Okay, and here's another one, the last one. Okay, and again they show these waves that surround that thing, and they say, look, this is the dunes we see on Mars. That's how they were created. So it's all about evidence. That's all that these people present. They present experiments to show you that here on Earth, with electricity, they can reproduce what you see out there in the night sky with great telescopes or with the probes that we sent out there. They take these close-ups and they say, look, here's these dunes. This is how we can reproduce them on Earth. So obviously, you have to infer that, or they tell you outright that this was caused by some electrical phenomenon. So what is the problem with all that? Well, the problem with all that is that evidence doesn't cut it in science. What you need is argument. What you need is a theory for science. We want to know the mechanism. And they do present a mechanism, and here is evidence that they present for example, for the fact that the astronauts went to the moon. Okay, they have two of these videos, and they say, look, with this we can show first that man went to the moon, and they were able to take all these pictures up there. So unlike the flat earthers, the official version of the electric universe is that man did go to the moon. So what is the problem with this? Well, the problem with it is that if as like they say, as they agree, I think man went to the moon as well, so I have no problem with what they're saying. Man went to the moon, and now they're going to present evidence. What evidence they present? Well, they're going to say, see, we took all these pictures of the dunes, of the craters, and how can they have been done? Well, they were done electrically. Well, in order to be able to do it electrically, you need plasma. You need a plasma out there in space to do electricity in space, okay? So what is the problem there? The problem is that the astronauts have gone to the moon 6 times. And all 6 times, not all 6 times, 4 of those times, they put a cathode, cold cathode ion gauge, okay, up on the moon. What is that? That's something that measures the vacuum. So if you're going to accept that that man went to the moon, you have to accept also the results of their experiments. And the cold cathode ion gauge shows that the moon does not have enough plasma to generate a constant current. Neither does Mars. Neither does the solar wind. Neither does any place in the solar system. And so here they're trying to create this electricity out there, and you need plasma. So here's the what they imagine, that there's electricity out there. You need plasma to run that electricity. Okay, you do absolutely need plasma. What happens? Man went to the moon. They accept that, and here are the missions carried out by the Apollos. Okay, whether you like it or not, this is the official version of the electric universe. Okay, and in 4 of those, number 12, number 14, 15, and 17, they measured the vacuum on the moon. They did not only measure it one day, okay, not only when the astronauts were out there. They left the cold cathode, the ion gauge up there on the moon, And they left it for several years. And from the Earth, they were monitoring the, uh, the vacuum on the moon, the pressure. So they could monitor it every time they, every day. And they monitored it both when the moon was showing its dark side to the sun and its bright side. And they noticed there was a difference there, but they were able to measure the, uh, the vacuum on the moon without any disturbance. And what they found is that the vacuum on the moon is in the minus 11, minus 12 torr range, which is probably among the highest you can achieve here on Earth. I never achieved it. I worked with vacuum many years with plasma, and we worked at the minus 7 level. I never seen minus 8. And these guys are talking about minus 11, minus 12 on the moon. The solar wind is in the minus 13, minus 14 range. It's even lower, okay, or higher vacuum, lower pressure. And here's just one of the reports. This comes from Apollo 14. And this is the formal report that came out a year later after the mission. It says 10 to the minus 12 torr. That's what's on the moon on an average, or in general. And then the solar wind is even in the 10 to the minus 13 torr. Okay, and just to give you a little idea, I always put this little vacuum levels there so you can see what we're talking about. For those of you who are not familiar with vacuum, 10 to the minus 3 torr level there, the plasma level, that's where we run production, because we know there's going to be, you need the bullets, and that's what argon, which is the species we use there. We ionize the argon, and that's what we're going to use as bullets to sputter a target. That means we're going to chip pieces of it like a machine gun shooting bullets against the wall. That's called sputtering. And we operate at 10 to the minus 3. Before we get to 10 to the minus 3, we have to pump the chamber down to 10 to the minus 7. And there are all kinds of problems. The big one being water, and another big one being backstreaming from the vacuum pumps. And so the maintenance guys have to clean the chambers. They have to make sure that they dry the chamber. They heat them up. They evaporate as much water as they can. And they have to turn the machine over to us at minus 7 level. Once we have it at minus 7 level, we introduce argon in there, take it to the minus 3. Now we can run a current, a consistent current, okay? The vacuum on the moon is 10 to the minus 11 torr. We're talking about anywhere between 50,000 and 200,000 particles or hits. That's the way the ion gauge measures that, per centimeter cubed. That's how this is measured. So it's got a vacuum level that does not sustain electricity. Let me repeat that. It doesn't have a vacuum level that sustains a constant flow of electricity. If you go into interstellar, intergalactic, you get it 10 to the minus 16, maybe even 10 to the minus 19 torr. Those are calculated values. These other ones are all measured values. Okay, let's distinguish there. So we have measured values. And so at this point, I have to step back take a step back and ponder something that for me has been bugging me for quite a while. You got a guy like Walt Thornhill, okay? And, he's a sounds like an intelligent guy, a rational guy. So the question I've got is, where's the failure? Is he ignorant of this? Is he just uneducated? Does he know? Is he aware that there's a 10 to the minus 11 torr level, minus 12 maybe torr level on the moon, and that he cannot run electricity at minus 11, minus 12? Is he aware of this problem? Is it he's willfully ignoring this because it, essentially kills his theories? Is he just bypassing and just saying, I'm going to present evidence of how electricity does all these things, and he forgets about the most basic thing, which is there is no electricity out there? Is he aware that the astronauts are not zapped when they're out there? I mean, if there's a constant electricity that keeps the whole solar system running because there's this electrical current running in space, is he aware that the astronauts are not zapped? They're not going into an electrical field, because to have an electrical field, you would need at least the minus 3 level. Does he know what species is out there? I mean, are we talking about ionization of argon, of some inert gas? Are we talking about ionization of hydrogen, of helium? What's out there? What is this plasma that fills all of space? Is it helium, argon, some other inert gas that I can't even imagine? Or is he ignoring this data? And this is where I have a problem because, these are the questions he would have to answer. And I'm wondering if he ever asked himself these questions. And if he did, how did he answer them? I mean, how did he bypass this and say, "Oh yeah, I'm not going to worry about that. I'm just going to continue." So yeah, this is where electric universe dies. We could stop right here, and we're done because if they cannot show a plasma out there, they cannot show electricity. And if they cannot show electricity, they can run a million experiments here on Earth with the electrical shocks, creating little volcanoes and showing how they match the ones on the moon or on Mars. It doesn't matter. Yeah, okay. So the electricity here on Earth, in your table or in your garage or wherever you did it, makes a little hole, makes a little mountain, moves the sand around, and if you take a picture of that, it matches what we see in Mars, on the moon, or wherever. So what? If there's no electricity out there, if your premise is already wrong, is not even wrong, it's irrational. Because if there is no plasma out there, there is no electricity, the whole issue is moot. It doesn't matter that you can reproduce the same effect over there, in your house, the same one that we see on the moon. I mean, for that matter, we can just go to Hollywood. I'm sure they can do some special effects that can mimic what we see on the moon as well. You don't need to run an experiment. They can probably do a thought experiment and just put it on the screen for you. Does that mean that electricity exists out there, that there is some electricity flowing, especially on a continuous basis, if we're going to explain gravity with electricity? If we're going to replace Newtonian gravity, whatever that is, with electricity and saying, "Oh yeah, the sun and Earth are electrically bound." Okay, that's the issue. So we could stop right here because we're essentially done with the arguments. But no, I'm going to continue because I want to make sure that you get all the uh, objections that I have against the electric universe. This is where they start usually. They love to see this. These are the filaments they talk about. Okay, this is another view of their filaments. Okay, and um, and so the question is, yeah, what are those filaments? Is that electricity? Is that what we're staring at there? Is that what that was? Electricity going from one galaxy to another, from one star to another. Is that what holds the universe together? For that you need what? You need plasma. Okay, and this is the way they visualize this. They say there's current going there. Okay, so you got to put plasma in there, right? Because if the entire universe is sending electrical shocks or constant AC or DC, like they said, I said it last time, it's a closed circuit. If there's a closed circuit out there, there better be plasma all over the place. So you need those little white balls in the background everywhere. And they have to be, these are not, by the way, this is not ether in this case. This is plasma. That means we're talking about atoms, we're talking about ionizations, we're talking about protons and electrons. So now we're no longer talking about ether here, okay? Let's make sure we distinguish that. Ether is what they used as a background to explain light. In other words, the undulation of the ether is supposed to be light. That's not what these guys are talking about. These people are saying something else. They're saying, look, what we have out there, we have tons of atoms. The universe is covered with atoms. Every millimeter, every centimeter, every micron, every angstrom is cut. Well, hydrogen atoms like a little over an angstrom, but you have every space in the universe has to be covered with some kind of atom. That's what they're saying. This is not ether. This is atom. We have a sandbox here. Okay, we're full of grains here. And what they're saying furthermore is that all these grains are ionized. So we got two things here. We have not only that we have atoms covering the entire universe. This is what they're saying. That's the only way to get this plasma thing. They have to have plasma covering the whole universe. That means atoms are covering the whole universe, at least at a -3 level, which is outrageous for space, for the vacuum of space, right? And it's got to be ionized by some process, because ionization doesn't occur spontaneously. You got to trigger it. You got to incite it. I hope you understand that. We could have introduced in our chambers, we could have introduced argon, and the argon would have just sat there. So you introduced us in here. What are we supposed to do now? No, the way you set them in motion, you got to ionize the argon. Now you can use them as bullets. Now you can manipulate them with magnets, that sort of thing, or send them against the anode or cathode or whatever. You can play around with all this stuff. But as long as it's inert, all you got is gas in a balloon. That's all you got. Is a gas in a balloon ionized? No. You put gas in a balloon, it's just gas. You want it ionized, you got to do something to it. And so if there's atoms out there filling all of space, that's not sufficient. That would already be a headache, because I don't know how they're going to get all these atoms out there. But on top of that, you got to ionize them with some kind of process. What's the process for ionization? Are they saying that this star over here is ionizing atoms and sending these electrons through a channel of ions or atoms from one atom to another? The electricity is flowing from here to the other star, let alone from one galaxy to another. Is this what they're saying? If you think about it, there's a lot of questions that raises. And again, I've got a problem with a guy like Walt Thornhill, who sounds like a reasonable guy, comes across as normal, and then he says something like that. It just blows me away. I'm saying, is he aware that what he's saying? Is he aware there's no plasma out there between the sun and Alpha Centauri? Do they really think there is a plasma out there, that the space is full of atoms, ionized atoms, and that a current is running from the sun all the way to Alpha Centauri, right through the astronaut? Is this what these people think? So yeah, it doesn't matter that they do experiments in their labs, in their garages or whatever, or on their table or kitchen table. It doesn't matter, because if there's no electricity out there, the experiment is moot. It's the explanation we're looking for. We don't care about their experiment. We want the explanation of how Mother Nature runs her shop out there, or Father Universe, Father Cosmos. How does he run his universe? That's what we want to know. If they're saying electricity, they need to put plasma, and they got to justify it. And here, the astronauts sent the ion gauges. The ion gauges are telling them there's no plasma at the 10 to the -3 torr level out there, which is what you would need to have a constant current flowing. Okay? I hope you understood what I said. Okay? Okay, here's the solar system version. Okay? We have current going from one place to another, and what they're doing is they're putting the sun at one end, Earth at the other, and notice that it's a closed circuit. Okay, that's important. It's got to be a closed circuit, otherwise that doesn't work. Okay, and they do say it's a closed circuit. That means, somehow current has to flow out of the sun and somewhere, maybe eventually to the Earth. But the way they run it is they run it through other stars throughout the galaxy, which is outrageous, absolutely outrageous. There's no possibility of any of that happening at all. Okay. And here's the definition of plasma. Okay, I showed that last time. As you can see, it's a dynamic process. It's not a standalone physical object, and it takes 2 years to convince an electric universer to understand that. And they don't understand it, because they would have to lose their religion in order to understand it. And just in case I rub it in one more time, gas is something that is fixed. Gas is a physical object. Plasma is not. I can take a snapshot of gas and it's going to be gas. I take a snapshot of plasma, it's not plasma. What I have is something static, and plasma is defined as something dynamic. In fact, If anything can be defined, it cannot be an object. No object can be defined in science or in physics. Another of the things that is included in the 21st century version of science, the way you do objects in physics, you point to them. Okay, that's how it's done. You point a name, table, tree, rock. That's the way we do it in physics. We don't say, let me define to you what a table is. Let me tell you what a rock is. No, no. You point and you name. That's how you present a rock in physics. You don't define it. You can later on define it and describe it. First, you got to point to it. That's how you present an object. So if you have to define the word plasma, for sure, it's not a physical object. And that's the difference. Concepts we define, objects we point to. Straightforward. And unless you understand that, you don't understand anything in physics. Okay, so you need to understand that. Okay, that's sine qua non. Okay, so what is ionization? Because you're going to need ionization to understand plasma. And here we see that the electron bead, this is you can think of it as a hydrogen atom. It loses its electron, okay? And the nucleus remains behind, it's positively charged. And this is the way it's explained in quantum mechanics. Under the rope model, we have a different version of ionization, too lengthy to cover it here. But here it is. We're going to go with their version, and we have that electron leaving the atom. And the only question we have here, which you have to answer, is why was that electron bound to the nucleus in the first place? Why didn't it spontaneously leave? See, in order to produce what you're seeing there, you need you need to incite it. You need to compel it from the outside. You need to do something to the atom to produce that. The atom does not disintegrate like that spontaneously. You have to do something to it. And so the question is, before you do something to it, why didn't the electron leave the nucleus? Why didn't it leave the proton? In this case, electron leaving a proton in the hydrogen atom. And yeah, this is a valid question. You have to answer that question. And of course, people want to avoid those questions because it destroys their theory. And quantum can't answer it either. And by the way, the electric universe is simply a branch of quantum mechanics. They've accepted everything practically from quantum mechanics, okay? Okay, so is that the planetary atom? Is that the atom that the electric universe is going to use? You betcha. Here you have Thornhill, and he tells you, in fact, he illustrates the atom for you, and he talks about orbiting and spin. So he's saying that the little electron bead is spinning, and it also orbits what? It orbits the nucleus, the proton, okay? And of course, you got several problems here. The first one is, why doesn't the electron leave spontaneously? You know, why does it go around in that circle? What keeps it bound to the proton? The other one is the mechanism they're going to explain, or that they're going to introduce as like a preliminary step for gravity. And they say, look, you have these electrons strongly attracted by the nucleus there, the one on the red one on the left, and also the red one on the right with respect to its nucleus. Those are tightly bound. But you can see that the one that's farthest from the electron that is farthest from the nucleus of the other atom, that's not strongly attracted. It's weakly attracted by the other nucleus, okay? And with this, they're going to say, well, see, this is the attractive force that pulls the atoms towards each other. We got a problem with this model, which is the quantum model, by the way. Don't the electrons repel the electrons? You know, we have these two outer electrons. Don't all these outer electrons, which are charged, repel the electrons of the other atom? I mean, you know, these people are saying, yeah, the positive nucleus attracts the electron of the other atom very weakly. Yeah, but in the same vein, we can say that the electron of the first atom repulses the electron of the second atom that's in its outer shell. So what have we learned? I mean, and by the way, this is just a waving of a magic wand. We don't know what positive and negative is here in physical terms. Why does positive attract negative? What does that mean in physical terms? And of course, they can't answer that question. They just say it is so, and they wave their magic wand, and you're supposed to accept it. Okay, and so then the question comes in, what holds the electron to the proton? We need to figure that out. And I colored that green area the other day, where you see E1. This is from their book, Electric Universe, okay, the beginner's view. And the question is, yeah, what binds the electron to the proton in the first place? That's the first issue. The second issue is, you have the electron going through the nucleus in p orbitals. The orbitals you're looking at there are s orbitals. They're called s orbitals, okay? But when you look at the p orbitals, you see that it goes right through the center of the nucleus. And here I'll show you a little picture of that, okay? And the p orbital is the one that's going sideways horizontally in a figure 8 way. And as you can see, the electron's going right through the center of the atom. I thought the center of the atom was positive. Why does the electron just go right through it and keep going? I mean, does a magnet go through another magnet, or does it get stuck to the other magnet if one is positive and the other end is negative? They get stuck to each other. And here they have them going right through there. This is totally irrational. And some people cheat and they say, well, the electron gets close to the nucleus, it doesn't really go through it. But they haven't answered the question. We still have negative very close to positive. And the question is, why doesn't it get stuck to the positive proton? That's the issue, okay? And so one of the issues that you have to answer is what holds the electron to the proton. And this is where we get into trouble with the electric universe, because they say it's the electromagnetic force. So we have the electromagnetic force is what binds the electron to the proton. Well, what is the electromagnetic force? I mean, these guys are the electric universe, right? They're experts at electricity and magnetism, one would think, right? Because they feel very strongly about their theory. So what is electricity, and what is magnetism, and what is electromagnetic force? What is this mysterious force? Well, they answer it at the bottom. We just do not yet fully understand this all-encompassing role of the electromagnetic force. Well, yeah, I mean, now, that's the question we wanted answered. That's the question. And hold it, they've been with us 200 years now. We've known about the electromagnetic force, at least, I would say, if not from Faraday, at least since the days of Maxwell. That's give or take 150 years. And we had quantum in between. They did all their experiments at these big labs, the accelerators, etc. And nobody knows what the electromagnetic force is. No one knows what they're talking about. No one can tell you the mechanism. And so the question is, if they don't understand it after 150 years, something has to be wrong. Something is amiss. I mean, how can it be that they cannot explain something simple? And you say, Bill, it's not simple. It's very complex. No. All you got to do is visualize it. It's kindergarten stuff. It's kindergarten. For sure, we don't need any math. No math whatsoever, no equations to see this. We need to figure out what this force is, because if there's a force, you can't use the word force. You got to put a physical object between the electron and the proton. You can't elude that, not in physics. In religion, you can put a spirit, or you can say energy. That's religion. In physics, you got to put a physical object. You got to put a stick in there. You got to put a spring. You got to put a rubber band, something. You can't just say the force, the electromagnetic force keeps the electron bound to the proton. You can't do that because you haven't explained the mechanism. And you can't say, well, let me describe it in mathematics. Here's the equation. This is how much force there is. I don't care about any of that. I don't care, because that doesn't tell me what keeps the electron being bound to the proton bowling ball from a qualitative standpoint. This is the issue. The issue, you have to tell me what physical object is there. You got to put your eyes in Mother Nature's eyes, or in her head, or whatever. You got to tell me what's in there. And you better put a physical object in there. Otherwise, you're going to be doing witchcraft. That's where we're at today. We're doing witchcraft because no one puts a physical object there. Everybody just, it's the force. May the force go with you. I need an object. I want you to put a stick there. I want you to put a rubber band. I want you to put an elastic band, or a spring, bed spring. Something that binds the electron bead to the proton bowling ball. Then you can go ahead and do your presentation. But unless you put something in there, you can't even start your presentation. You're lying. You don't know. You've got nothing to teach because you don't know. And you can't say, well, someday we will. No, no. Then we'll wait till someday for you to give your presentation. How's that? You can't give your presentation because you do not understand your own theory. You don't understand it if you cannot tell me the mechanism of your theory. Okay? And here's a summary of what is wrong or what is irrational, really, where the electric universe fails. And it's first, there is no plasma in the 10 to the minus 3 torr range in space. That's the big one. We can stop right there and go home because they can't answer that question. And they do accept that humans have gone to the moon. They know that 4 of those missions, if they don't, they should find out. 4 of those missions at least put ion gauges on the moon that measure the vacuum level. The vacuum level has been measured consistently over a period of years in the minus 11, minus 12 range, minus 11, minus 12 torr range. You cannot run a current, a consistent current at minus 11, minus 12 torr range. That's the end of the electric universe. I'm sorry. That's it. There's no more than that. We don't need to go beyond that. That's the first part. And but do we stop there? No, we have the EU cannot rationalize its planetary atom. It cannot tell us how the electron bead is connected to the proton bowling ball. They simply took Niels Bohr and Ernst Rutherford's atom, their planetary atom, and that's what they're using. That's what they're doing ionization, plasma, and electricity with. They're doing it with the planetary atom. And you say, okay, no problem. But before you get that electron out of there, before you ionize it, before you create your plasma, before you run your electricity, show me your atom. And what I mean by that, show me how the electron bead is tied, is bound to the proton bowling ball. If you cannot show me what, if you're going to use the word force, well, you're full of caca. You got to show me the physical object that binds them. You can't say the force does it. Okay, and that's the problem. They say electromagnetic force and they just continue. That's where they stop. That's where we stop. Okay, and then what I'm going to explain next time, today's too lengthy to cover this subject, is that electric gravity doesn't work. It doesn't work. Even if we grant their atom with a force, we grant ionization, we grant plasma, and we grant their electricity, their version of electricity, which is the flow of electron beads. Whoa, I went out of focus there. That's better. I don't know. Camera that I bought is new and it fails me. Um, even granting all that, they cannot explain gravity. It just doesn't jive. You can't make it work, not with electricity. And so I'm going to go over that next time. I'm going to introduce a fellow who was the guy who came up with this stuff for the electric universe. Okay, his name is Sansbury, Ralph Sansbury, and I'll be talking a little bit about him and his relationship to Wall Thornhill next time, so that we cover gravity, electric universe gravity. We finally get to it. Okay, but these milestones had to be set, and people need to understand them before we can get to that point. So study them. You'll be tested on this on Sunday. We'll see you then. Bye bye.